Hello, saver! Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 24, Episode 93, for broadcast on the 13th of August 2021. Coming up on SpaceTime: software failure blamed for the loss of space station control. New models show that mountains on neutron stars may only be a fraction of a millimetre high. And the launch of the first reconfigurable commercial satellite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The Russian Federal Space Agency Roscosmos has blamed software issues for the sudden thruster burn aboard Russia's new Nauka Multipurpose Module, which sent the International Space Station out of control for 47 minutes. Control was lost about 3 hours after the arrival of the new module, when its thrusters suddenly ignited, pushing the space station 45 degrees out of orbital alignment as the huge array flew at some 28,000 kilometers an hour, 400 kilometers above the Earth's surface. When they realized what had happened, Russian controllers in Moscow used thrusters aboard the adjacent Zvezda module to try and stabilize the orbiting outpost. But that only led to a tug-of-war between the two modules trying to counteract each other. Eventually, the thrusters aboard a docked Progress cargo ship were also fired up by Moscow to provide the additional thrust needed to bring the space station back under control until Nauka's thrusters finally ran out of propellant. The 20-ton Nauka had been launched aboard a Russian Proton rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan 8 days earlier, docking onto the Earth-facing port of the Zvezda service module. The uncontrolled thruster burn was the latest in a quarter-of-a-century-long string of problems with the 13-metre module. See, Moscow first began building Nauka back in 1995. It was initially meant to be a backup for the Russian Zarya control module. And it was then expected to ultimately replace the Pirs docking port module, which joined the space station in 2001 as a temporary addition. But ongoing delays with Nauka meant Pirs ended up being permanent, remaining in orbit for some 2 decades. The Russians only jettisoning the Pirs docking port to make room for Nauka once it arrived in orbit. Nauka should have launched in 2007, but was repeatedly delayed by ongoing technical issues. Then in 2013, metal contamination was discovered in its fuel system. That resulted in a long and expensive clean-out, which took so long some of its components passed their use-by dates. And that forced Russia to build an entirely new fuel system from scratch, further delaying the launch. Then there were even more technical issues, repairs and upgrades, further slowing construction. The total build time eventually reaching 26 years from start to launch. It'll take several months and multiple spacewalks to fully integrate the new module with the rest of the space station. However, its stay as part of the ISS may not be long. Moscow is now building a new module which will be the basis of a new Russian National Space Station. Roscosmos says a review of the Russian section of the International Space Station has highlighted a considerable amount of old and worn equipment. Moscow originally said it was leaving the space station in 2023, however recently that's been pushed back to 2024. And while a final departure date isn't certain, it's now likely to happen sooner rather than later. That's of course assuming they can build the new module more quickly than the 26 years it took to build Nauka. This is SpaceTime. Still to come, new models of neutron stars show they have mountains, but those mountains may only be fractions of a millimetre high. And the European Space Agency launches the first reconfigurable commercial satellite. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
New models of neutron stars shows that their tallest mountains may only be fractions of a millimetre high due to the huge amounts of gravity crushing down on these ultra-dense objects. When stars reach the end of their lives, having fused most of the hydrogen in their core into helium, the balancing act between gravity crushing a star down towards its centre and nuclear energy pushing outwards ends, and gravity wins, causing the stellar core to collapse inwards under the star's own immense weight. All this additional mass crushing down on the core causes a dramatic increase in pressure and temperature, eventually triggering a helium flash, making it hot enough for the core to begin fusing helium into carbon and oxygen. Eventually, stars like our Sun fuse most of their core helium into carbon and oxygen, but because they don't have enough mass to fuse carbon and oxygen into heavier elements, the fusion process ends. The star's outer gaseous envelope detaches and floats away as a planetary nebula, leaving the stellar core exposed as a white dwarf, which will then slowly cool over the eons. However, stars far more massive than the Sun face a very different fate. Because they're so massive, with higher temperatures and pressures, they end up fusing hydrogen into helium through a different process, and they then go on to fuse progressively heavier and heavier elements: carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. But no matter how massive a star is, it's not big enough to fuse iron into heavier elements. And so, ultimately, the balancing act between gravity crushing down on a star and nuclear energy pushing outwards does reach a final conclusion, with gravity again being the winner, causing the star to collapse in a spectacular explosion known as a core collapse supernova. What's usually left behind is an intense, dense object, a neutron star. Although only a dozen or so kilometres wide, neutron stars are the densest objects in the known universe, other than black holes. In fact, just the sugar cube size of neutron star material would weigh 100 million tonnes. Neutron stars are thought to be composed of a solid, rigid outer crust or shell composed of ions and electrons. Directly below this is a fluid inner crust made up of electrons, neutrons, and atomic nuclei, a neutron-proton Fermi fluid and electron Fermi gas outer core, and an inner core composed of quark-gluon plasma. Because of their immense density, which is equivalent to that of the nucleus of an atom, neutron stars have an enormous gravitational pull, around 1 billion times stronger than that of the Earth. This immense gravity squashes every feature on the surface of a neutron star down to minuscule dimensions. And that means these stellar remnants are almost perfect spheres, but not quite. Whilst they're billions of times smaller than on Earth, these surface deformations on the perfect sphere are nevertheless known as mountains. The study's authors used computational modelling to build a realistic neutron star simulation and then subject it to a range of mathematical forces to identify just how mountains on neutron stars are created. They also studied the role of the ultra-dense nuclear matter in supporting the mountains, and found that the largest mountains produced were only a fraction of a millimetre tall, 100 times smaller than previous estimates. The study's lead author, Fabian Gittens from the University of Southampton, says for the past 2 decades there's been a lot of interest in trying to understand just how large these mountains could be before the crust of the neutron star breaks and the mountains can no longer be supported. Previous work suggested that neutron stars could sustain deviations from a perfect sphere up to a few parts per million, implying that the mountains could be as large as a few centimetres. These calculations assumed that the neutron star was strained in such a way that the crust was close to breaking at every point. However, the new models indicate that such conditions simply aren't physically realistic. Gittens says the new results also suggest that observing gravitational waves from rotating neutron stars may be more challenging than previously thought. Although they're single objects, due to their immense gravity, spinning neutron stars with slight deformations on their surface should theoretically produce ripples in the fabric of space-time, gravitational waves. Gravitational waves from the rotations of a single neutron star have yet to be observed, although future advances in extremely sensitive detectors, such as advanced LIGO and Virgo, may hold the key to probing these unique objects. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
We've talked about neutron stars, and I guess we should probably revisit what a neutron star is before we talk about the mountain ranges that exist on neutron stars. Now, I as I read through this, it got more and more extraordinary. When you talk mountain, you're thinking huge obelisks of stone, and of course that wouldn't be the case on a neutron star, but they do have mountain features, just really not quite big ones. It's bizarre.
Exactly. It is, isn't it? And I think this is a great story. Once again, it shows the power of the theoretical physics that goes into understanding things like neutron stars. So what's a neutron star? It's in some ways it's related to black holes, because when a massive star gets to the end of its life, if it's massive enough, it's big enough, it will explode in a supernova, its core will collapse, and if that core is big enough, it will overcome every known force of nature and collapse to become a black hole. But there's a kind of intermediate stage for smaller, less massive stars, maybe 10, 20 times the mass of the sun when they start. Their core collapses, and if it's less than, I think it's 2.2 times the mass of the sun, the mass of the core. If it's less than that, it will collapse until the pressure of neutrons, the outward pressure of neutrons, actually stops it collapsing any further. So it's on its way to being a black hole, but not quite big enough to do that. And that's how we think neutron stars are formed. There are many, many of them known. Once again, they have very strong magnetism and beam out radiation from their poles, like the sort of thing we've just been talking about. But if they're rotating, these beams of radiation sweep through the universe, and if the Earth happens to be in line of one of those, you get this effect just like a lighthouse rotating, and we call them pulsars. That's what a pulsar is. It's a rotating neutron star. So that much is all known. We know they exist because they were discovered back in 1967 by Jocelyn Bell Burnell, who I'm delighted to say is a friend and former colleague of mine up in the UK. We used to work together at the Royal Observatory in Edinburgh. It was actually Jocelyn's work that not only proved that neutron stars exist, but also led to people believing that black holes could exist, because until then they were perfectly theoretical. Anyway, that is all the backstory. What's the front story? It is that researchers have looked at the structure of neutron stars, and neutron stars having magnetism sounds a bit weird because neutrons are electromagnetically neutral. So that we know that there is a mixture in there, which includes protons, which are electrically charged. And in fact, I think some of the thinking is that these neutron stars have a crust of different sort of material around the edge, quite a thin crust, but relatively rigid. I didn't explain, by the way, that a neutron star is typically 10 to 20 kilometres in diameter and contains the mass of a star, up to 2.2 times the mass of the sun. So the density is in the region of 1 billion tonnes per teaspoonful.
Good grief.
That sort of density. Yeah, it's crazy stuff. And that means that the gravitational pull at the surface of one of these things is about 1 billion times what we experience here on Earth. So
you'd be quite small if you went there.
You would be quite small, as are the mountains. That's the critical part. It's that gravitation that stops this crust having bumps in it bigger than a few tenths of a millimetre.
Wow.
I know, it's madness, isn't it? So you've got this ball 10 kilometres in diameter and little dimples on it that you can barely see because they're so small. And so what it means is that neutron stars, I think it's probably the case that they have seized the record, theoretically at least, as the most perfectly spherical bodies in nature. That record has previously been held by, any guesses?
Oh, gosh. Black holes?
That's a good guess, actually. You might be right, too. But it's not. The one I'm thinking of is the sun. The sun is...
Of course. I knew that.
Incredibly, perfectly spherical. Yeah, sorry.
No, I'd heard that before, and it just, usually my brain doesn't let me down like that.
Mine always lets me down like that. Yeah, so the sun, for all its 1.39 million kilometres? I think that's right, in diameter. The biggest departure from a sphere is 10 kilometres, which is just amazing. That's 1 part in 100,000 or something. It's just phenomenal.
Yeah, well, compared to the Earth, because we bulge because of our rotation, our spin.
That's right.
Yeah.
And the spin of the sun is quite slow. That's probably why it's so spherical. It's 25 days on the equator. It's different at the poles because it's not a solid body. Yeah, so it looks as though neutron stars take the biscuit in terms of being perfectly spherical. Maybe perfectly smooth is a better way of putting it, because I guess they could still bulge at their equator.
They're the billiard balls of space.
Yep. It's funny how we all think of billiard balls, but that's basically it. That's very smooth.
I don't know why.
I think of that as well.
Yeah. Funny. Oh, I was just looking at your head. Sorry.
That's actually quite smooth too. It's within 1 part.
Yeah,
1 part in 1,000, probably.
you could have neutron star properties there, Fred. I think perfect roundness.
Actually, the main neutron star property is that it's very dense inside. Totally dense brain. Yeah.
No one can accuse you of being dense, Fred.
Oh dear, I've been called worse than that, I can tell you.
Haven't we all? Oh dear. Glad those days are gone. Okay, so mountain ranges on neutron stars are minuscule. Minuscule, we'll call them that. Right. So you won't trip over them. But then again, if you do ever travel to a neutron star, you'll end up being smaller than the mountains, I would imagine. Yeah. Due to the gravitational
forces. I suspect
forces.
As you got near it, you'd be spaghettified like you would with a black hole because the gravitational potential is so intense.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come. The European Space Agency launches the first reconfigurable commercial satellite, and later in the science report, a new study warns that COVID-19 infection could result in memory trouble. All that and more still to come on Space Time.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
The European Space Agency has launched one of its last Ariane 5 missions, successfully placing 2 satellites in a geostationary orbit, including the first reconfigurable commercial satellite. The flight from the European Space Agency's Kourou spaceport in French Guiana delivered the Star 1D2 and Eutelsat Quantum spacecraft into their respective geostationary transfer orbits.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain, image AP, décollage.
The 6,190kg Star 1D2 satellite was released 28 minutes after launch. Built by Maxar Technologies in Palo Alto, California, Star 1D2 is a high-capacity multi-mission satellite equipped with Ku, KAC and X-band transponders. They're designed to enable it to expand broadband coverage to new regions in Central and South America and to add an updated X-band payload for Brazilian government use over the Atlantic. The Eutelsat Quantum satellite was deployed 36 minutes after launch. The revolutionary 3,461kg spacecraft was developed by the European Space Agency and Airbus Defence and Space as the first universal satellite designed to be repeatedly reconfigured to meet changing requirements. Unlike conventional spacecraft, which are designed and hardwired on Earth and really can't be repurposed once they're in orbit, the Eutelsat Quantum is equipped with flexible software and electronically steerable receiving antennae operating in Ku band, together with 8 independently reconfigurable beams, allowing it to change footprints and consequently mission profiles, making it the first of its kind. This is Space Time.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that simply isolating the most vulnerable in our community isn't enough to protect them from COVID-19. The findings, published in the journal Scientific Reports, are based on data from 1.3 million patients around Glasgow between March and May 2020. Of this group, 27,747 were considered to be at high risk and were told to self-isolate for extended periods of time, while a further 353,085 were considered to be at moderate risk and were not told to self-isolate. The authors found that compared to low-risk individuals, people who had been advised to self-isolate were still 8 times more likely to have confirmed infections and 5 times more likely to die following a confirmed COVID infection. Moderate risk individuals were 4 times more likely to have a confirmed infection than the low risk group and 5 times more likely to die following a confirmed COVID infection. The data shows that self-isolating only high-risk groups isn't enough to protect them, and other population-wide measures need to be implemented at the same time, such as social distancing, face masks, and hand hygiene. Meanwhile, a new study has suggested that COVID-19 infection might result in memory trouble. A report in the Journal of the American Medical Association found that 11% of participants reported memory problems 8 months after a positive COVID-19 test, compared to only 4% of people with negative COVID-19 test results. The study included some 13,000 participants from Norway who completed an online questionnaire during their COVID-19 test and again 8 months later. The World Health Organization says more than 8 million people have been killed by the COVID-19 coronavirus, with over 4.4 million confirmed fatalities and more than 205 million people infected since the deadly disease was first spread from Wuhan, China. A new study has shown that combining different types of pesticides and herbicides used in farm chemicals poses a greater risk to bees than previously thought. A report in the journal Nature shows that agrochemicals were found to be influencing bee behaviour in a synergistic manner, meaning that the combined effect of the chemicals interacting together was greater than the sum of their individual respective effects. Scientists say that current bee protections don't take into account the synergistic effects of agrochemicals and therefore underestimate the level of danger that intensive farming environments pose to the pollinators. A new study has found that Australian women are having babies later in life. The research by the Australian Institute of Health and Welfare shows that 1 in 4 women giving birth in Australia were 35 years or older. That's an increase of 7,000 babies born to mothers 35 and older in 2019 compared to 2009. While mothers aged 40 or more did have a higher risk of some complications, the Institute says the risk factors for women aged 35 to 39 were still comparable with that of younger mothers. Older mothers were less likely to smoke, less likely to live in low socioeconomic areas, and more likely to live in cities. Well, it's hard to believe, but it seems Sydney's Wakehurst Parkway could be Australia's most haunted road. The parkway winds its way through a national park behind Sydney's northern beaches. For more than half a century now, the road's been linked with sightings of an eerie female apparition looking like a nun or wearing a faded wedding dress. The ghost, known as Kelly, who was apparently a slain hitchhiker, or so the story goes, suddenly appears in the middle of the road after midnight, hovering just above the ground, only to mysteriously disappear as terrified motorists swerve to avoid her. Others claim to have driven past the grey silhouette of a female late at night, only to then suddenly find her sitting in the back seat of their car, before just as suddenly disappearing again. It's worth pointing out that these stories have only come to light as filmmakers put together a documentary about alleged ghost sightings in the area. The documentary is being made with the help of no less than 3 psychics, so obviously very creditable and well researched. The 14.6 kilometre long Wakehurst Parkway does have some history. It runs from Narrabeen to Seaforth and has been the site of one horrific murder and dismemberment, the location where a decaying body was found that had either been strangled or suffocated, and where discarded items belonging to a murdered schoolboy were located. Although no slain hitchhikers as far as we know. Tim Mendham from Australian Skeptics says a pair of ghost hunters investigating the paranormal are also claiming to have encountered Kelly's spirit while wandering the road late at night.
The Wakehurst Parkway in Sydney runs from Manly area and the northern beaches around in a big circle up further up the North Beaches. So it goes inland a bit and then comes back around.
It's the back road behind Narrabeen Lagoon.
Some have suggested it's the most haunted road in Australia. Not from my experience, but then perhaps because I've only ever driven along one section of it, which I must have done at least a couple of thousand times. The other section is a bit spookier because it goes through bushland, heavy bushland. Actually, most of it goes through heavy bushland. And there's supposed to be hitchhikers and all sorts of things out there that suddenly appear in the back of your car or in front of the car or whatever.
Are they one-armed hitchhikers with hooks?
Yes, it's described by a USO proponent that this road is known for falling into near total darkness at night.
Which is better than doing it in the daytime, I guess.
That's right, but I don't know, that necessarily means you're going to have a ghostly hitchhiker or something.
Have there been many slain hitchhikers on this road?
Not that I know of. It's not the sort of place you get a lot of pedestrian traffic on, in my experience, daytime or nighttime, because there's no footpaths along the side of it. And if you're going to walk along it, you're really going out of your way, and there's probably better ways to get to where you want to go. The stories could be anything, quite frankly. I mean, people misinterpret stuff all the time. And I know someone who's sort of a chance acquaintance or something, a friend of a friend who actually does claim to have seen the hitchhiker.
The ghost of Kelly haunts the Wakehurst Parkway, it says here.
Good.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.